Hello, everyone. This is Nathan, otherwise known as Old Man Builds, and I have Mr. Lenios here today. And we're going to talk some cool stuff about some generator technology from Tesla. Also, we're going to look at the uh, the Faraday motor in conjunction with that. So, with that said, Mr. Lenios, you want to introduce yourself?
Hey, everybody. I'm Mr. Laney. I know there's confusion about the name. It's like miscellaneous, but it's a play on the word. It's Mr. Lanius. But I'm so excited to be part of this community. I was first turned on when homopolar generators were discussed. And that's kind of what I wanted to get at today. I'm kind of under the weather, so it's going to maybe be brief, and we'll get to other people here soon, hopefully. But so the Tesla homopolar generator, it's actually a bipolar generator, if you will. So you can either use an electromagnet coil here, which would be underneath, or a permanent magnet, and say this is the north center and this is the south center. As this is a conductive belt, so he's spinning it with a conductive belt, and as these two discs spin, the electrons here, say, will experience a centrifugal force due to the Lorentz force, okay? Comes through this conductive belt and goes centripetally towards this terminal, and then it comes out to the load, and the cycle repeats with this conductive belt. And he taps it off right here, and it lowers the friction of the homopolar generator. And spin on it was using fluids instead of solid discs. And just keep this in mind as I present it. It's kind of heavy, so I gotta hold on one second. I'm just now streaming for the first time, so I gotta get used to it. But
yeah, we're all good.
It's this guy here I've been working on in the background. It's the same thing. I ordered the parts and just threw it together as a prototype demonstration. But so I'm just using two drills as the motors there. And inside these jugs would be a conductive fluid. They look blue because I was using copper sulfate. But I have speaker toroidal magnets on the bottom and everything, and I tap it off from the bottom there. But it's the same principle. You're just spinning a conductor through a magnetic field and using Lorentz forces to generate high current. Now, it's high current with very low voltage. That's the whole point of these generators. But they can easily get up to 100 volts. Then you can tie that in with any high voltage generator, and then you get a hybrid system where it's similar to the Statica, where he used a Wimshurst type of high voltage generator. These can go easy 1,000 volts. So if you were to have married together 1,000 volts conservatively, 100 amps conservatively, that's 100 kilowatts. Okay. The Testatica actually powered a small community. I think it's Meternita in Switzerland or something. And it's really the practicality, like in a grid down, you take jugs, you take speaker magnets, conductive fluid. So the power system's easy, and the focus of this channel, I believe, is the propulsion. And that's where I'll get into later. But I just close this so that nobody can patent it. I just want to give it away. And yeah, if anybody tries to patent it now, it's public information. They can't. And just a basic prototype like that, you can spin off of it so many different ways. You know, mercury would be better than an electrolyte. Just so many different ways you can take it.
Whoop, sorry. Sorry about that. I clicked the wrong button. Playing around with how things are working. Right on, man. That's really cool. So let's get into the how the energies combine, because a lot of people are not going to understand that right away. So can you explain that?
That is tricky. There's several ways you can do it. Like I said, the Wimshurst is probably not the best. I mean, you could do it with the taser module.
Yeah, kind of missing you there.
Yeah, my camera went out. That's okay. You can do it with any high voltage generator. You can use the back EMF to separate the say battery pumping an inductor, open the circuit with the relay and use the back EMF. And that way they're separate, because that back EMF will give you a high voltage that can be sent through that. And since the battery circuit's open at that moment, they're isolated. That's one way of doing it. Another one is an Avermenko plug. One end connected to ground, and then the other end, the two diodes that split off, you can use those two. So, if you know about Avermenko plugs, you're converting the AC to DC, but it's a one-line system where one line is connected to the earth, and then the two diodes are where you would send that voltage through the bipolar, I guess I'll call it Tesla fluid turbine or fluid dynamo. But there's several ways if you're creative. I can maybe discuss more on it later. I literally just built it within this past week to show today.
Okay. Well, I always have to ask, because you know what? Sometimes people get into things and they go, well, this is just an amp motor. And then they go, well, this is just a voltage source. And combining the two makes a big deal in understanding how to get generators to work better. Because sometimes you want something that produces pure amps so you can get them higher. Sometimes you want pure voltage, but the combination really makes the biggest factor out of everything.
Yeah, and imagine, one of Gerald's coils being pumped with 100 kilowatts. You're going to get some propulsion if you know how to do it.
Yeah, we're getting there.
And it's funny, my video went out. Like I said, hopefully I don't attract bad attention, but I'll get my message across as long as I can, if you guys are willing for my camera to be down at this moment.
It's all good, man. We're good. If your camera goes down, you got to show your project. That's really
I got it in there.
Yeah, just in time, huh?
So it's public information, guys, and I'm not trying to be, but if you were to patent something like that, it'd be slap secret anyways, but it'd be worth a lot of money, and I just want to give stuff away. Now, when it comes to Electrets, it is a lot of labor, so I have to charge, but I am going to give 5 away, especially one to Sean because he's been inquiring, but I'm still waiting on some equipment for those. Electrets are like fine wine. Sometimes they can take a month to actually set if you look into how to make Electrets.
Okay.
Yeah.
So, can you talk about that? You said the fluid in the bottles that you had there. Can you just describe that and what it does and how it's a fluid? Because it looked like it was like crystalline or something in there at this time.
I siphoned all the fluid out to demonstrate it because it's too heavy to lift. But
okay.
I was using copper sulfate originally. Vinegar and salt's actually a really good conductor of electricity. Just a highly conductive electrolyte, but you can use mercury, liquid metals and stuff like that for, like really low resistance, high amperage types of systems. But just for somebody to slap something together, if the grid goes down, you got, salt water, and you got some speaker magnets, you got some big jugs, and you can spin it. I'm a practical guy, and I want to get the information out, for practical reasons. And you don't have to go into. You can make really powerful ones, but you don't. It's just slapped together and it'll work.
Well, it's interesting because Bernie does a lot of electrolysis. So would
Yes,
this tie in to help with that?
yes, yes, yes. Electrolysis, the high current of these generators is, with Faraday's laws of electrolysis, it's really more about the current. Um, yeah, and there's electrolysis going on when you do this with an electrolyte naturally, because uh, the high current through the going to produce, it's going to outgas oxygen and hydrogen, but you can combust those too and use that as well. Using liquid metals, of course, you'd avoid the electrolysis, but yeah. So it's basically like in one of the jugs, you get a compression of the current, and then when it goes through the load, it the other one because it's having that centrifugal force.
Okay. So, sorry, did you cut off?
No, I'm here.
Okay. It's all right, man. Sorry. Let me see. They got a question in here. It says mixed vinegar with copper sulfide is toxic. Let's see.
That's good to know. I didn't know that.
Well, yeah, now we know. Let's see. Walter Rust, I can't read that name. Final setup is making FE devices and creating an electret. Okay. So I'm actually interested in this. We were talking about 2 weeks ago, as we said earlier, about the homopolar generator and how it just puts off the amps. So let me ask you something. You said that Tesla did it with a belt that goes around it. Do you think that belt was getting electrostatics to add into the amperage on that motor?
Yeah, Tribal Electric could play a part there, but he used like a conductive chain kind of thing, from what I understand. So he was going for a low resistance, but you can increase the voltage with Tribal Electrics, that type of effect with the, you need a low resistance, but you can still triboelectrically charge it as it's doing it to get some natural voltage on it.
Well, I asked that because you basically can take a static generator and put brushes on the belt, and you're going to get an electrostatic charge. And then you get the motor turning and you get the amps coming out of the homopolar motor right there.
Right.
So I'm just wondering if in some way you'd still have to recombine them. You know what I mean? Just kind of like you're doing.
Yeah, the recombination is where I'd have to get a little bit deeper at a different time. Yeah, but know that there is a small community that's powered with Testatica, and it's a similar system.
Yeah, we looked at it on this channel a little while back, and some of the interesting stuff about that is how they're taking the energy and transforming it as they went along the line. Did did you get into that whole thing a whole lot?
I just built it, honestly, and I'm still trying to think if I want to Avermenko plug it or if I want to just send some back EMF through it, or even just run. If I just ran it with a Wimshurst, you get the issue where the Wimshurst is a very high resistance. So if you just plugged it in there, I don't expect much. I can try it just to try, but I'm expecting you're going to have to isolate the high voltage and the high current and then combine those two down the line.
Okay.
But it's going to take some exploring, and it's an easy thing that this community can build, and then once we get a pretty powerful source for propulsion, we're off.
Cool. So let me look up that so people know what we're talking about. Oh man. I can't find it now. How do you spell that Testica? Do you know?
Testica, I think. Testatica.
Yeah, there we go. Okay. Now here's what I want to get into. So let me pull this up and I'll share the screen here. Um, so this is the Testatica machine here, and we looked at this a little while back. Let me see if I can't get a better picture of it. Right here. So what I always, let's see, it didn't change. Hold on. There we
Someone
go.
asked if I'm spinning the jars. No, I'm spinning an electrolyte with those two drill motors. The jars remain stationary.
Right on. So, okay, so let's take a look at this real quick. This is the Testatica machine. So, do you think on that backplate you see the stuff that looks like the Wimhurst? But do you think there's also a homopolar, or basically a magnet behind it, just like the?
Well, you see those two black knobs on top of the two condensers or capacitors that he was using, those big jars. It's similar to mine, right? There's
Right.
two. Imagine if it were a motor, or if there's a spiral coil going down the middle of those capacitors, it would produce the magnetic field without using speaker magnets, kind of thing.
Okay.
Those jars he used was the big secret, you know what I mean? And my twist is, using those jars as a homopolar generator, or bipolar, really. But
Well, in doing this, it basically is taking, there's static electricity there, but if you combine it with the homopolar, I keep saying that, just combine it with the magnet and get straight, you know what I mean, amps out of it. Then you can combine them in that thing there, or you could just do the back as the homopolar generator, and then you could use in basically a DC flyback setup in those two cylinders in order to get an AC, basically a potential voltage coming out of it.
right, I would say a slower pulsed flyback type of thing would be the first way I would try to go about that. It doesn't have to be high frequency or anything, because just want to build up a current into a coil slowly and then rapidly open the circuit, and that's where you get that high voltage, but that's sent through the canisters, if you will. And while it's doing that, your battery is then open, so that they're isolated, because you're opening the switch, battery's isolated, but that collapse is going through the two canisters, so you get the voltage while the battery is even open.
It's interesting. Yeah, I would just, because you're basically getting amps in there, so you're getting a magnetic volt, or however you want to say it. It goes into the center of the canister and creates an electromagnetic field in there, and then it can go through each one of those layers that's in there, and that can create your high voltage coming out of it. But you can also, if you recombine it, take out of that magnetic field the amps itself, and then recombine them in the center there where you see the horseshoes.
Yeah.
Then you can recombine it right there, and you'd have a whole bunch of energy for an entire place.
Yeah, if this system combined with homopolar generator is studied by us further, I think it would be a good starting point for a power source for propulsion, because you're going to have a pretty powerful system to get it going. If you want to get off the earth, you know what I mean? It takes a small community generator like that to get you there.
Yeah, I think that's one way to go. I think Gerald's producing a ton of energy in his coil that'll actually give us what we're looking for in the way of the ether inside of it in order to get that extra energy. So it may turn out to be that in itself is the power source along with the actual fields necessary to create the craft.
Yeah. Yeah. This is the power source. The propulsion I have, if I can share, let's see. Hold on one second, please. So just a basic thing when you have, a poloidal wrap is this. This is like the center of a donut. And when you're wrapping this way, you get what's called an A field. Also the magnetic vector potential here. Okay. And when you have like a permanent magnet in a coil that's just wrapped this way and you pulse the coil, the electric field is the A field is the electric field, but it looks like a magnetic field. It's an unconventional electric field basically. But when you have a permanent magnet here, it's magnetically parallel to this A field. You get a vortex spin, and that's why the magnets will spin if you pulse it correctly. Just having this wrapping, those coils go around. They're beautiful in geometry, but every time it makes this loop, you get an A field, and I call it the Ghostbuster field. They say don't cross the field A and B perpendicular. It causes the magnet to spin. But to get propulsion, you can use this A field with an electret here, and it'll bounce the electret up. Spin, it's good to use a magnet in there, but if you use an electret in here, you literally get a bounce because this A field resembles an electric field, but you have to pulse this poloid, if that makes any sense.
Makes sense. One thing that I found is when you do this, it matters if it's, how do I want to say this? Normally we wrap coils like this, okay? And start wrapping them like this around the donut, right? In order to create the direction to be correct. So when we do the coils, we do designs in different angles, but they're more flat, right? So it's creating a different geometry to get it in there correctly. So the fields themselves will come out curved. Does that make sense to you?
Yeah. When you wrap it, like, if I can reference one more thing, hold on a second.
Yeah, you got it. Reference everything.
Let's see. So yeah, the wrappings, like this would be a 1-to-1 wrapping kind of thing.
Okay.
See? And there's this axis that's black, that's your what's called toroidal axis of rotation. Around that, this way, what we were talking about is the poloidal axis of rotation. And this is just a 1-to-1 orbit of one toroidal to one poloidal, gives us this elliptical type of geometry, right? And this would be like a planet, and this is the sun. But the ellipse is really three-dimensional. It's going along the toroid. And with Gerald's coils and all that stuff, they're basically manipulating the toroidal versus the poloidal geometry, which is going to give you different magnetic and magnetic vector potentials in the center here, right? Poloidal, toroidal. And this is just a paper I wrote like 10 years ago, showing a three-dimensional version of Kepler's laws instead of two-dimensional. But, when you do 1-to-1, like we said, it's an ellipse. You do 2-to-1, 3-to-1, and you start getting into higher patterns that are conic sections. The 4-to-1 pattern is more like a galaxy. The The stars resemble more like this around the galactic center, but in our solar system, the planets look like this around the sun. But when you zoom out, a star around the galaxy goes more so like this. And let's see if I could find it. But basically, precession leads to this type of pattern, where, well, let's see. This is kind of the fractal version, if you will, that I wanted to share with Victor. But so as a model, that helps me just visualize the universe. I like to have a good model. So this is a solar system. The square gray is represented here, right? So this, when you zoom out, you get into an interstellar type of frame, okay? And the small frame is now here. This black frame, you zoom out and it's here. You get more of a galactic frame here, right? And then this frame, purple, is here. When you zoom out, it's more intergalactic. This blue frame, zoom out, it's plasma type of construction, plasma cosmology. And they say 99% of the observable universe is plasma, right? And keep zooming out, this blue frame, what if it's part of another star, because the star's plasma? And then, so we're starting with another solar system on a complete different fractal level. We started with this solar system, now we're at this solar system. And we keep zooming out, this green frame's here, it's part of a, interstellar, galactic, large-scale plasma, which is part of another star, and it goes on forever, And there's the time difference between these two, is humongous. The radiation of this star would be c squared compared to the radiation of this star. It's a fractal radiation. And because it's a fractal forever, it's infinitely dense, but infinitely thin. And that's why whenever you accelerate something through space, you get length contraction like this, because it's like drag in the air, but it takes really high speed to sense it. Like in the air, you can kind of feel it with your hand going really quick, but in the fractal universe, you have to accelerate really high to actually sense it. But that's the whole contraction, is because it's a drag on the fractal vacuum. Let's see. Hope that made sense.
No, it made sense. Sorry, I'm following with you. It's kind of hard. I don't see your facial expression, so I don't know when you're done presenting sometimes. So that's my fault.
Oh no, I'm sorry.
That's okay.
But by those beautiful patterns, and somebody was saying if we can get Sheila, like she's really good too. But what I think about those coils is it'd be cool to wind them separate, where you just to study, just wrap one toroidal and then wrap poloidal around it, just to study the relationships between length, resistance, and all that stuff. And if you drive them with two different channels of a frequency generator, you can do Lissajous figures and study it that way, but for practical purposes, it's good to start there. And then you can make those beautiful geometries once you understand the principles, and they do the same thing.
Well, do you think they're two different fields?
Yeah, the magnetic field is when you go with the toroidal type, and then the magnetic vector potential is the poloidal.
Okay, so let me bring this up and share. So you've probably seen this image before?
No, I haven't.
Oh, you haven't seen this before?
No.
So this would be what we're looking at in the Van Allen belt. It would also be what we're looking at is, kind of what the Earth produces. And then also this is our mindset when it kind of comes into coils and things of that nature on the fields that are created.
Yes, absolutely. Like the Earth, it's 70% salt water. And like my generator I showed earlier, like it's literally spinning in a magnetic field and producing, you know, similar high current effects. Yeah, the Earth itself is, you know, a dynamo, but I don't believe it's the iron that's causing the dynamo effect. You know, it could just be salt water spinning in you know, a charged, negatively charged surface of the Earth spinning will produce a magnetic field by itself. You don't have to have iron or anything like that. Any charge that spins creates a magnetic field. You know, and there's a difference between intrinsic spin and literal spin, but I'm talking about like literally like an electret just spinning, a macroscopic electric, not an electron, will produce a magnetic field just by spinning it.
Okay. So let me ask you this while I had this picture up before I take it down. You see the inside here? It has, if you can see where the mouse is going, it has what you're talking about. Yeah, it's a poloidal is what you're talking about right here on the donut shape. Okay. But it also has this field that comes out way out here. So what I've noticed is that's almost a scalar field that comes out here. It's not quite electrostatics. Sometimes it can be converted to electrostatics if you don't have your distancing right, but it's more of a scalar energy, and it continues to build in these things as we're going. And then we get, because of the poloidal in here, we're getting heat to push out this field right here because it's creating the magnetization around the entire thing. So it forces it out, which also means that on the inside, we're also getting it to force inward, which means that all the stuff that comes in through the outside here is now compressed.
I can see that, yeah. With the blue field poloidal that you're mentioning, when we call it the magnetic vector potential, when it's related to the electric field, it has to take a pulse, okay, because it's dependent on the rate of change in that poloidal field in order to produce it. If you just ran it static, it would not do anything. You have to pulse that poloidal type field in order to get electrostatic type of fields.
I agree. You still there?
Yeah, I'm here.
Okay.
Sorry. I'm getting notifications and stuff.
Oh, okay. I thought it disconnected on me or something.
But yeah, I kind of been feeling under the weather. I was hoping somebody else can jump on, and I just love hearing you guys. Or any further questions, I can answer them. I'm just not feeling too good today, but let's go, guys. If you want any further breakdown.
Okay. Give me a second. Can you see the screen?
So one A field has zero divergence and the other has non-zero divergence.
Okay.
So the divergence, and that's where it's related to the rate of change. And all goes back to Tesla. He was saying it's more about the rate of change than the frequency. The frequency is easy. I mean, you just put it into a tank circuit, and the frequency is just your harmonic, you know. But the rate of change is where you get these divergence in the A field. It's really a matter of quickly opening and quickly shutting the circuit, like Steinmetz said.
Okay. What about Electrets?
Yeah, Sean, I'm going to give you a free one, buddy. I'm so sorry. I'm still working on it. I'm having website issues. I can't receive email right now, and I don't know if anybody's tried to email me. the best email for me right now is mrlaneusengineering@gmail.com, and not that website. I'm working with GoDaddy and trying to resolve the email issue right now. But Sean, I'm going to be giving you a free one, bro. Whenever I got it, you're definitely going to get one. And I want to give 4 more away too, but please explain your experiment in order to get one if you want one. I don't want to just give them away willy-nilly. But hey, if you got a cool experiment, let's do it.
What are you guys exactly talking about there?
The Electret, you see this emblem with the hand holding?
Yeah.
Amber is actually the origin of electricity, if you will. The Greek word for amber is electret, or electrum, or something like that. But yeah, it all started with amber, and that's why I have this embolism here. But an electret is just a permanently charged electric field instead of magnetic field, and you really can't purchase it on the market. You can get electric microphones and stuff, but what I'm talking about is macroscopic electric charges, and I'm the only person that I know of that is willing to make them and sell them, or charge, if you will, for a pun. But I have no problem giving them away for free for experimentation. The equipment I do have to eventually charge to recoup what I had to pay to make these. It's an art, it's really difficult, but they'll be coming out here soon.
Well, it looks beautiful. I'll be honest with you. I'm looking at it. That's really amazing.
See that custom Electrets, it's that white emblem is the C, and then on the right side is the E, but flipped over. That's why it looks like that. So CE. I don't know if you can make it out, but yeah, I'm talking about Electrets like that have a huge charge, and the difference is volume charge density. My Electrets are bars and not surface charge. That's the difficulty. And once you get high volume charge, that's where Bueller comes in, and Pius. They're all seeking that high charge because Pius was only able to get like 10 to the negative 8. And just one coulomb is a huge amount of charge. One coulomb is huge. So it's about the volume density that I'm going after, not the surface charge density.
Gotcha. Okay. Hold on. What Mr. Lanio said about the frequency was important. The fact that V-Fed can control AC motors was quite an accomplishment.
I'm sorry, I'm not sure what VFDs are.
Basically, variable feed drives, if I'm not mistaken. Variable frequency drives, sorry.
Okay.
Yeah, basically just to run your three-phase AC motor.
Yeah, and sometimes variable frequency can be made with parametric resonators. Parametric resonators are interesting for variable frequency type of driving systems, I believe.
Okay. So was the high voltage AC or DC?
The high voltage,
I would imagine they were talking about your first experiment.
well, that was the example was a Wimshurst machine, which is DC, but that's not necessarily what I would go with. It was just to demonstrate, theory. Like I said, I would use back EMF because you're opening up the source, and you're isolating the voltage and the current and combining them. Versus a DC, it's really cool. It's an influence machine. Electrostatic motors and stuff are really interesting to study because they're cheaper. A bunch of copper it's hard to produce a permanent magnetic motor. I've heard of people doing it. You got to gate it and do all that stuff. But with Electrets, you literally could just take 2 Electrets and spin, and you get an electric motor very easily, just having a positively charged electret and a negatively charged electret. When you study electrostatic motors, you can see the future is going to be more electrostatic. And Jeff Amenko, he described how to make a electrostatic motor that's a cubic meter that can get I think it was 100 horsepower. But it takes really different thinking about electrostatic motors versus magnetic motors.
Well, electrostatic motors, you can start removing all that iron.
Exactly.
I mean,
It's
you can
much
use,
cheaper.
yeah, you could basically use aluminum. You can use plastics and things like that.
Right.
You can use plastics with some metal in it if you wanted some form of charge in there.
Right.
So,
The way I think about it is, imagine being the guy back in the day, and people are like, so what is this magnet? Right. And it led to the Industrial Revolution, and if you can say, hey, look at this electric, people are gonna be like, well, what the hell do I use this electric for? You be creative, and it's endless what you can do with them, but they're not available, so I'm trying to make them available.
very cool. So I got a question for you on this. So you talk about electrostatic. So, and you talk about back EMF. Usually when we talk about back EMF, we look at someone like Bedini, where he creates a spike, okay, and then he's capturing the spike in the battery. Is there a correlation at all with the static electricity in the back EMF?
Yeah. If you take like a neon and look at just the back EMF on a neon, the interesting thing is only one side of that neon will light, and it's the negative side. So it's different, but it's a high voltage spike that's just literally the change in the basically whenever it collapses and it has nowhere to go, the more resistance, the more that collapse will actually increase. And it's very non-intuitive, because if you have like a low resistance collapse, it takes a while. But if you have a high resistance on that collapse that you collect, the magnetic field rapidly collapses. And it's all distance that you feed through the diode on that back EMF on the rate of that collapse of the magnetic field.
Okay. It's just interesting. He uses a battery and the acids inside are automatically converting from back EMF, you know what I mean, to a DC frequency or a DC voltage. I'm sorry.
Yeah, and I do recommend Rick Friedrich. I know he was like kind of shunned from that community, but he actually, shows dual battery systems and has done a lot of investigation into it. And it's a really good source for Bedini. Like once you learn Bedini and you go into Friedrich, it'll expand your ability to use and bounce them back and forth. And Benitez, he patented, and his patent, the cool thing is he shows the formulas of how to do it. So look up Rick Friedrich and the Benitez patents that he discusses. Look at the formulas, and if you really want to know what's going on, Benitez puts it straight there in the patent.
Very cool. Okay, we got another question here. There you go.
Yes, Victor Grabenikov, like he's so cool. Yeah, I mean, there definitely is. I mean, there's even stories of magic carpets back in the day made of, ink, and I suspect that's kind of a Cavener structure effect. What was his name? The king of Israel, Solomon.
Okay.
Legend says that Solomon had a flying carpet, and like that's the true origin of it. And I think they were using inks that, were very cavernous. And the cavernous structure effect is very interesting.
I agree with that. Kind of in some cases acts just like a resonance chamber when you get that cavern, and then you're going to get a frequency that repeats.
And he was using de Broglie type of relations to explain the cavernous structure effect.
Okay.
De Broglie waves, if you want to get into the math.
Gotcha. Huh. Yeah, talk about Gorbachev. Always bring up the bugs.
It would be so cool to hang out with him when he was doing that.
Oh yeah, it would.
Like I heard it was he had to time it like it seemed from his book like the sun played an influence. If you wanted to go a certain direction on Earth, he'd have to wait for the sun to be in a certain position, which is interesting. So if you wanted to go east west, he'd have to wait until the night to go back, and vice versa. Like he had to use some influence from the sun in order to accomplish what he was doing.
That's interesting.
Yeah.
Totally interesting. How does that work though? I mean, what if you need to go left and it's only going to the right?
Right. But he's just strictly working off, electrostatics. When you want control, you have to, of course, have magnetics and stuff. But his was just like he used a Van de Graaff, I believe, to charge the wings. And I believe, he didn't want to disclose, but I believe they were scarabs. And I don't think he wanted to disclose that because scarabs are sacred, from Egypt and everything. But on top of the king's chamber, there's actually a layer of scarab shells, and I think that's hinting at that even the Egyptians kind of knew, electrostatically that scarab shells had this type of levitation property.
So you say it's on top of the king's chamber? There was scarab shell?
Yeah, there's a layer of scarab shells up there.
That's interesting.
Yeah.
I never knew that.
Yeah.
Huh.
And scarabs, the funny thing is they follow the sun, and that's where Viktor Gorbachev gets into it too. Like some influence and everything, like it's all solar based. So there's a link.
So what do you think about people doing that kind of replication where they make the box and they get things to kind of lift off of it?
It's hard to tell, honestly. I mean, it can be fake. It's hard to tell. See, the way I think of propulsion is completely different than that. I can see the links, but my way of propulsion is different, so I can't tell just by a video.
Gotcha. So how would you describe the propulsion then?
Well, I would say with that magnetic vector potentials, it takes a pulse, right? And that magnetic vector potential produces something analogous to the electric field, but that electric field looks like a magnetic field. The geometry of it looks like a magnetic field. So it's not your conventional electric field between two plates. That's linear. This is, toroidal. And if you put an electret there and say you just used rubber, okay, you used a poloidal wound coil and put a rubber balloon membrane there, put an electret in the middle and pulse that poloidal coil, it'll jump, but you got to time it. You got to time the jump. You got to time the pulses so that each time it jumps, it resets and then it jumps again and it resets like a squid in the water. I call it a buoy ball because I don't want to call it anti-gravity, but you're kind of the buoyancy of the electrode, if you will, in the air. When we say it's anti-gravity, you get negative attention. But if you just say, hey, we're just exploring the buoyancy of air, just call it a.
Still there?
But I don't know if that made sense.
Yeah, I kind of cut out some of it.
Uh-oh. I'm sorry, guys. I had a feeling it'd be glitching out a little bit, but easy propulsion is just using the magnetic vector potential by pulsing a poloidal round coil while having an electric in the middle. But when you have the magnetic field too, that's where you get a vortex. Okay, if you just want a solid propulsion, all you need is a poloidal round coil and an electret. But if you want text and have more control of just going up, you know what I mean, and have more control of left and right, you're going to have some sort of magnetic field involved with that.
Okay, so let me ask you this. When you get to a lifter, would you say that that would be poloidal, or would it be the other way?
It's both.
So can you explain that a little bit to people?
So, like, are you talking about electrostatic lifter? Let me make sure. We're not talking about gravity flyer.
No. I'm just talking about just what they would call an ion lifter, but if you get the energy right, it's not an ion lifter at all. So that's why I'm asking the question.
Well, the ion lifter, like I said, is just lift, and you don't get that, left and right and more control that you would with something like Gerald's coil, because it involves the toroidal and the poloidal, and having them both on two different channels of a frequency generator gives you much more control of your magnetic field versus your magnetic vector potential. So it gives you more control. Using something like Jared's coil is art. You know what I mean? Like that's where it's really related. But just for experimenting, you can literally just take one coil and wrap it conventionally toroidally, and then wrap another coil around that poloidally, put them on two different channels, study Lissajous figures with it. We know about magnets, and once electrets are available, you can start doing those experiments.
So let me find something here for you, and I'm going to ask you about it real quick. Let me find Gerald's channel, because he had a lifting experiment, and I just kind of want to get your take on it because of what you just said. So let me find it. Man, I don't know why it's not automatically right here. Oh, there it is. Okay. That's the one I want right there. Okay.
Monday show. Here's what we got. We got the primary and the secondary both being pulsed at the same coils, modified Joule thieves. They'll be pulsed at 1,000 hertz, 10% duty cycle square wave with 20 volts per pulse. We're going to turn the primary on in 3, 2, 1. You guys have all seen this before, of course. It's levitating about an inch above the magnet. We're going to turn the secondary on in 3, 2, 1. Now we got about an inch and a half above the magnet. That's pretty cool. It's neat and everything. Check this out. Let's see if we can hop it while levitating. In 3, 2, 1. Whoa. Now let's see if we can bring it up and keep it there. In 3, 2, 1. Interesting. All right, everybody.
Really cool, man. It's really about that sudden switch, though, that made a jump. You know what I mean? And if you can time it just right, where it jumps and then jumps and then jumps, as soon as it starts to fall back down, lift. But you got to time it, and you got to have something on board to where the lift it can lift the actual power supply. You know what I mean? That the power supply is external in this case, but you'd have to have the power supply on board, pulse it, boom. As soon as it starts to fall back down, pulse it, boom. But the lift has to be so great that it lifts the power source with it.
Okay. Well, just in this setup where we're not worried about the power source, we're just worried about the actual coil. What I was talking to Gerald about is it's creating the magnetic field under it, kind of like, I don't know how you would say it, but it's just like a bubble. And then every time that you pulse it, if you can stay on top of that bubble, it moves with it up. So what is your opinion of that?
I'm gonna have to look more into the bubble. So is he using two different frequencies and two, like I say, toroidal and poloidal windings? Or see, it's hard to tell, and that's why it's important to be more in depth about this toroidal and poloidal type of speak, because then we can know more technically about the windings, you know. And the poloidal is not really discussed much, but they're both important. And you got to know, is it a solid coil? Is it two separate coils?
They're two separate coils, and they're wound within each other.
So wound within each other.
I want to say braided, but there's no third line in there.
Yeah, so what I'm thinking, it's so every time, like a rodent coil, every time you make a loop, you get one unit of magnetism in the middle toroidally, one loop toroidally. But each time you go around that donut poloidally, you get the A field. So it's the combination of the A and B that gives you the vortex. And you know, so you'd have to say for one loop you get one unit of magnetism, and then one poloidal you get one unit of vector potential.
Okay, so I looked at this. This is kind of one of the keys to my actual gravity flyer right here. Is this effect? So I was looking at this, and like you said, if he continues to get that pulse, he doesn't need the magnet on the bottom. He only needed it to start.
Okay, that's cool. So he can remove the magnet from the bottom?
Well, that's what my hypothesis would be on it, that he can remove it. And based on the field, once it gets up in the air, that magnet's too far up to affect it, or too far down to affect it.
Well, let's just take like a practical example where a rubber balloon were stretched like a membrane on top of that coil. And instead of using the magnet on the bottom, you just set the magnet in the smaller magnet in the middle of it. And because the, you know, hysteresis of that balloon being a practical thing, you know, it's like a drum, if you will. Then once the magnet and the coil interact, you can have a better understanding than the magnet just being below it. I would explore using a rubber membrane with that type of experiment, with a small neodymium in the middle, and trying to pulse it, and seeing if you can time the pulsing to like have it lift, and then as soon as it starts to drop and catch up, you pulse it one more time like a squid. Or jellyfish. Think of a jellyfish, right? You know, but by using a rubber membrane, it's really a practical way of doing it. Is, you know.
Okay, so now I wanted to ask you, since you had said in the comments over time, bismuth. Can you explain that when it comes to the gravity flyer?
When I did research on it, it's been a while. The original guy, I heard he used bismuth, and that's just why I was interested. And I agree with you, aluminum, you know, it's key anyways, and why add stuff to it. And I agree with all that, but there's an interesting relationship between the paramagnetism of aluminum and the diamagnetism of the bismuth. And I believe that diamagnetism gives you the platform, the ground, if you will, to push off of. You know, so what's it going to push against? And it's going to be that bismuth layer on the bottom of the aluminum to give it something to push against, because the magnetic field's going to be repelled by that. Give it an artificial ground, if you will, something to give that bubble resistance, because it's diamagnetic. And it takes just a thin layer of bismuth, and it would be below the plate, the aluminum plate, just a thin layer below it, you know, just literally just melted on there and smeared.
Okay.
Just to experiment with, because, you know, the original inventor used it. So like, let's see why.
Well, I didn't realize that he used it at all, and I've never seen it on his machine. And Charlie C has the original, and it wasn't anywhere on there.
I did research on that so long ago. I wish I had the resource on it, but I know somebody else in the chat was chiming in with it and saying, yeah, he did, and blah, blah, blah. But I couldn't reference you. And that was during a time where I was just deep diving. And I did hear that he did use it, though. So it's just, and even ice is highly diamagnetic. You may not even need bismuth, just like literally like freeze the plate with a thin layer of ice on there, and it could do the same thing.
You say just get the plate cold?
Yeah, just put it in the freezer, and then right when it's frozen, explore it really quick and see what happens, because it's got to be deionized or distilled water. It can't be tap water, but it's highly dielectric and it's highly diamagnetic at the same time. So water is really just such an interesting material. You'd have to have Peltier devices and stuff to keep it frozen if you wanted to do it for a long time, but just to just explore, take it out of the freezer and just quickly do experiments with it.
So I gotta tell you something, and you can tell me what you think about it. My gravity flyer, the center plate gets really cold in the center, so it'll drop 20 degrees, okay, without a problem. And on the outside, I still get a real ring of say hot or heat, but in the center, it's cold. It's not really going to show up on your camera when you go in there to get the temperatures on stuff. You know what I mean? As a hot layer, it's going to show up as a cold layer, and it has to do with the way I'm tapping the Tesla coil. I'm literally pulling the cold energy out of the center of that Tesla coil and putting it directly on that center plate.
Yeah, I agree. Electricity is where I get really interested, because usually whenever you get cold, you're on the right track, right? Tesla, his thing was creating and you can use the heat of the surroundings to power things. And anytime you get cold like that, it's really interesting. And just thinking of just a conventional refrigerator system, okay, it goes through what we would say a load for an electrical system and dispels the heat, okay? But in a refrigerator, it then goes through a countercurrent exchanger and then in an expansion valve, right? And then to the evaporation coil where it cools the electricity or the refrigerant, okay? So by picking that with electronics, you can do that. The expansion valve, though, takes something like an SCR, really quick expansion, just like where you have a spray can, you let it spray, it'll cool down. It's that rapid expansion that cools it down. But, we don't use something like a countercurrent exchanger in electronics. The closest, was Tesla's pancake coil patent. It resembles a countercurrent. When you use circuits like that, aren't thermally conductive. They hold the heat in. They can't expel the heat. They'll just melt the insulation. But something like ice or diamond or something that is thermally conductive while being insulative allows the heat to come in and out. And so it's important to use the dielectrics in those. And you can have a countercurrent heat exchanger type of situation, and then expand it with an SCR. And once you expand it, you get cold current. But what you're talking about field wise, it's really hard to wrap around right now. And I'd like to explore it, but it would take a lot deeper thought. But I like to see it like a refrigerator system. We're missing the countercurrent heat exchanger. We have an SCR for rapid expansion, but it puts out the heat. But then you have to suck in the heat on the other side, just like a heat pump.
So, how much do you know about what I did on my gravity flyer?
I have to do some more research. Like I said, it's been only a week since I joined this community, and I love you guys. You guys are so cool.
Well, that's why I ask. I just don't know, how far you got into it and what I found. So
yeah, I'm definitely going to deep dive into it.
Well, I say that so 'cause I'll tell you about it just a little bit so that you can get a better picture of what I'm doing. So what I'm doing is the high voltage itself that goes in on the top and bottom plate. I'm not looking at all to get like a static electricity. I want the scalar electricity, okay? Or I want to get basically how do I say this? I want to get a dielectric effect between the bottom and top plate. And I want to be able to use the eddy current to be able to drive the motors not at the same speed, but be in the same area when it comes to resonance. That way that they can move together. So now, when I know that, I'm looking to saturate my center plate. Because my center plate's connected to my Tesla coil and this down the throat of my Tesla coil, it's producing cold electricity in the center of the Tesla coil. Because it's coming out pulse that allows a pulse signal to go into the center, we're getting 25 megahertz coming out of that frequency in the center. My Tesla coil only resonates at 310. That means the vibration on my plate is causing my frequency to go up. So what I'm looking to do is when we take that piezoelectric buzzer is I want to be able to push down on that bubble that's being created. So one of the secondary effects of the Tesla coil is it creates a field around the entire craft. What happens is when the top and bottom discs get all that electricity in them, it's now pushing out a field there. So it's pushing out that scalar field, but it's being stopped by my Tesla coil field right there. So it's kind of halfway between static electricity and the scalar in that range right there, and it's holding in that field, so it's filling the bubble. Now, when my Tesla coil is connected the way it is, and the gravity flyer is sitting on the ground, it's acting as a pump to the ground itself. It's pulling in energy from the ground. So we're getting another amount of energy that comes in. The way that it actually shows on my oscilloscope is through 3 rings. I'm getting 3 ring signals on my oscilloscope. Now, every time that I pulse my piezoelectric buzzer, they amplify. Depending on where you amplify them is how much power you're getting out of it. Now, the last part of this that I have to do is on the outside edge, I have to be able to bend that edge. And it wasn't seemed it would be that important, but it is when you start talking about the static lifter, and it's not exactly static electricity like everybody thinks. It's more of you're pushing into one field and the other field is responding, and based on the amount of the mass that you're pushing against, it's always going to try to go towards a smaller plate. So it's kind of opposite of what people would think it would be, but that's the way it's working.
So are you using asymmetric capacitors, if you will? So one's smaller and one's larger. Discs.
No, they're the same.
Okay, so in diameter, they're
yeah, the diameter, they're exactly the same.
Okay, and then you say you have a Tesla coil in the center of those plates, or
it's connected to the Tesla coil on the center plate through the throat of the Tesla coil. It's not actually connected directly to the Tesla coil.
Okay, so like the Tesla coil is like the Tesla coil is an external power source to the plates.
Yes.
Okay. And yes, it's just I'm gonna have to look at your videos. Honestly, it's difficult for me now, especially being kind of under the weather. But is there a specific? Are you wondering why it gets cold, or?
Oh, I know why it's getting cold.
I'm interested in that. Like I always seek the endothermic things because that's a good sign, you know.
Well, it's getting cold because it's how do I say this? I'm robbing the energy from that Tesla coil, and I'm doing it basically by putting I don't know if you'd call it load or capacitance on it. In one way, it acts like capacitance, and another way, it acts like load. But you're basically taking the energy out of the center of the Tesla coil, which means that as the Tesla coil goes like this, you know what I mean? The field comes around. It's basically pulling that center part. So you can call it ether, you can call it what you want, but it's basically pulling that coldness to the gravity flyer, kind of like cold electricity does with that light bulb. It pulls the energy into it. So it's like a suction to it, right? And then as it's sitting on the ground, that suction is pulling energy from the earth. Okay. Just like you could hook up your Tesla coil and it runs horribly without a ground line. And then when you hook something into ground, it automatically picks up an energy by a lot.
Yep.
Well, that's kind of the same effect that I'm getting here.
Do you think it's more reactive power or active power? Do you know?
I know it's not explosion. It's more of an implosion.
Yes. So power comes in so many different flavors, you know, like reactive power is basically that power that oscillates back and forth. And they say you can't use reactive power, you know, and I suspect you're more using reactive power in this situation, which is, you know, what Tesla was doing with what he called concatenation. And a lot of people don't go even there, but concatenation is reactive power into active power. And the active power is what gives you heat, you know, but the reactive power is said to do nothing. And you have to convert it with concatenation type of methods like that. But definitely implosion is where you get the implosion of the magnetic field specifically is where you get that cold, because you can use a relay and mechanical relay. And when you open the switch, like the core of that relay gets cold just because of the difference between the slow buildup of the magnetic field and the open, and then it collapses. The core of the magnetic, the relay gets colder just because that collapse was more rapid than it expanding in its field. It's rate of change. It's all that stuff. Just like refrigeration, you can't just, you know, run something without some sort of rapid rate of change.
So that would be where the DC flyback comes in, because it's giving you the heat in the system to the cold on the center plate.
DC flyback?
Yeah, so it's basically on the top and bottom disc. It's connected right there, and it adds a bit of heat to the system.
When you're doing a flyback, are you building up a magnetic field, opening the source circuit, and then controlling it with a diode?
Yeah, we're getting a slightly magnetic field because the aluminum won't let it stay on it.
Yeah, the aluminum's paramagnetic. Yeah, so I really want to look at your yeah, like if you I know it's kind of hard, but if we can email each other and you can send me some really good videos that you would like for me to look at. It's just so hard to visualize for me right now.
No, it's not a problem. I just everybody, you know what I mean, tells me about it, so I just like to ask sometimes, you know what I mean, to
Absolutely.
see what, you know what I mean, what they think about it. More than just a couple sentences that you could put in a, you know what I mean, a chat. So
Right.
So it's just interesting. So
who's your favorite inventor, Nathan?
You know, Tesla.
Yeah, Tesla, man.
Yeah.
Yeah. I like Sparky Sweet. He's kind of cool. But my favorite, Thomas Henry More. I think he's really, really cool.
Thomas Henry More. Didn't he make hold on, did he make a radio?
He started off with like crystal things and discovered this Swedish stone, he called it. And once he discovered that stone, he was able to like use crystal radio type stuff to first power a small light bulb and then kilowatt range at one point. And he had to use grounding. Grounding is very important, you know. But yeah, I suspect he was picking up what my research would say is called auroral kilometric radiation. And this
Okay.
is the radiation that happens above our atmosphere that puts out a signal that's higher than any military broadcaster that you can even imagine. I mean, the power it literally puts out is huge. If you were an alien looking at the Earth, that's the signal that would be the dominant signal, say AKR radiation. So I suspect he was tuning into that. But yeah, his circuits were cold, and that's my interest is that endothermic. It points me where I want to go.
Was he also in rotation? I'm trying to think of his radio.
His radio?
Did he? I might be thinking of the wrong guy, but
He invented something where you could hear miles away. I mean, it's related to radios, but if you could look up Thomas Henry More real quick, I think the viewers, if they're not familiar with him, he's my favorite inventor. I love Tesla too. You know, it's hard to say who's the winner, but he's just my favorite. And this is so documented. It's just indisputable what he was doing.
Okay. Thomas Henry More, inventor, right?
Yeah, Moray. Moray. He wrote a book called The Sea of Energy in which the Earth floats.
Okay. Well, okay. They don't have the book. I'm getting a couple of, let me see. I'll just share the screen.
Yeah, he was able to hear miles away with his type of, I guess you call it a radio, is like an audio sensor, a hypersensitive way of listening in. It's just very bizarre things he was doing.
Do you see his picture on here? Is it one of these people?
So instead of Moore, it's Moray.
More.
There you go. Yeah, that's the guy.
That's the guy right there?
Yeah, so he was using the first image there. Like he would strand a horizontal antenna, ground it, and use something like a crystal radio to get kilowatts of power out. And so many different people try to debunk them, and it was just not, they weren't able to debunk them. Travel through glass panels. He's just one of those rare guys that popped up and just disappeared like so many of us.
I'm going to have to look more into him myself. I wonder. Yeah. So it kind of sounds like what Tesla was doing when he tried to pull his third type of energy when he pulsed the Earth.
I thought I heard that he was actually a protege of Tesla. So he carried on Tesla's, from what I understand. And so did Sparky Sweet, supposedly.
So I'm kind of running one of those experiments myself. I want to see if I can't ping the Earth. I got to hit the water table first. And I want to put the rod in the ground and put the Tesla coil over it and kind of get the same type of energy I'm getting to my gravity flyer, but I want to get it down on the Earth, and I want to see if I can't pump it.
Have you ever heard of an UFER ground? UFER?
No.
It's made of concrete, but it's a really good grounding method. Also, you could take a stainless steel canister, fill it full of, say, activated carbon, and then put some sodium hydroxide in there. And that's a great ground too. You know, and Tesla actually used panels instead of rods. And what you're looking at, the surface area two, and a panel has more surface area than a rod. I wouldn't just drive a rod in as a conventional ground. You really got to think about that ground. If you're already putting, say, sodium hydroxide there, you're getting electrons for free because alkalis readily give up their electrons, and then the earth just resupplies it. So that ground is important, and it takes some thought about how to do it. You can even, some people would ground trash yards and stuff like that. So great because all the microorganisms and stuff. Even a fence, because of its large surface area, a metal fence is a great ground. That's how they used to ground, and they go and use their gutter. In crystal radio, they use a fence as the ground, and the gutter, as long as the gutter is not grounded, it would act as the higher aerial, if you will. So you got your ground and your aerial, and then the crystal radio would go in between that, and you can catch signals much easier.
So I wanted to check out the water as a ground when you put the rod in the ground. You know what I mean?
Okay.
To see what'll happen. You know what I mean?
Drive it deep and pee on it.
I don't know that I want to do that, to be honest with you. That's great. Right on, man. Okay, hang on a second. Let's see, I'm checking the chat right now. Sorry, I just want to see if there was any questions about anything. So a dual ground system, yes, that is exactly what I want to do. Basically, you know how they always say that when you ground it, it's like a circuit connected. Well, I want to see it.
You might be interested in earth batteries. They were doing that, 2 separate terminals, and if you align it correctly with the dip of the magnetic field of the earth, you get what's called telluric currents, which naturally happen. And they're diurnal currents that are always there. So earth batteries are a really good grounding source too.
Hendershot generator. You heard of that one?
He was doing what I was saying about the reactive power to active power conversion type of transformation. Did he have one center coil, and then he would have smaller cylinder coils around it? Is that Hendershot, I believe?
I'm not familiar with what he did, to be honest with you.
But that would, if I'm thinking of the right guy, that would be how you would want to convert your reactive power to active power kind of thing.
I'll have to look into that then. Let's see. He said yes. That's
yeah. I know what you're talking about.
okay.
Yeah, he powered a boat, right? I think, but it's been so long since I looked at that, and that's where I would point to convert it out with. There's differences in power between reactive and active, and that's how you would convert between the two.
Right on. I'm gonna have to look that up for sure, because I might need that here in the future. Let's see. Anything connected to the water table is an antenna.
Yeah, just the ground into the ocean. There you go too.
Yeah. Let's see.
Any source of
go ahead.
Alkali is the best ground, because alkalis readily give up electrons, and acids are more receptors of electrons, if you will. So acids want to absorb electrons like a sponge, and your basics, your alkalis, will readily give up electrons. So an alkali ground is really basically a free source of electrons.
Right on. So, hey, I got to ask Sean while he's in the chat here. Hey, Sean, do you mind if I show your ground wire on your Tesla coil? So, Let's see what he says. That thing,
I'm
man.
sorry I'm not feeling too well, guys.
Yeah,
I got
that's
too
wild.
juiced up about this chat. I was chiming in left and right and like trying to work on that, fluid Tesla dynamo, if you will, in the background. I'm just worn out.
Oh, yeah. Well, trust me, man, it's been that kind of a time for me too. So I'm trying to do experiments and run different shows, you know what I mean? And find time to pick stuff up and watch my granddaughter. And
That's why I appreciate you so much, because there's so much work in the background, and I just really appreciate this platform and what you do for us, Nathan. I really do.
Well, it's important, man, because I know I don't know everything. And then everybody in the crew, they don't know everything. So when we all get together, we know a heck of a lot more. And being that we're all inventors, we all get to be able to talk in the same language. You know what I mean? So
Yeah.
it's a lot easier to be able to do that, because now we can build off of each other's work. You know what I mean? And be able to get the little detail we needed for ours. Maybe not it's a big deal to them, but to us and what we're doing in our little project, it's a big deal. So it's like an explosion of different cross thoughts and how they work. So I really love doing this.
Yeah, and I searched around really trying to see where, because this is my first live stream, where I want to enter, and you're the man. This is where I want to go. And I have a lot of projects for us up, and I've got some stuff coming, guys.
Right on. Hey, Sean, did you is it okay if I show that video that you sent me earlier? So sorry. I see him in the comments, but he didn't answer yet. So
He said, I'll be showing my experiments on how to pump electrons from the Earth this Wednesday on Nathan's channel.
oh, he's gonna show it this Wednesday. Okay. There you go.
Cool beans.
Yeah, he's got some amazing stuff going on. Sean's always working on something.
Hey, Sean, have you ever tried to pump the electrons and send it through an Avermenko plug?
Oh, let's see what he says. Huh. Well, it said looking forward to it. Interesting. Yeah, you know what? I think honestly, have you seen what he does at all?
I've seen a little bit. I started chiming in about a week ago, and I saw his sphere where he was getting that fractal type of awesome high voltage stuff going on. It was just mesmerizing when I was watching it. It's just so beautiful.
Oh, it's kind of hard to see kind of when I show it on the live here, but when you see it in the regular video, that thing's like 18 inches in the air, those sparks.
That's huge. It's like 1,000,000 volts if you do it by the breakdown of air kind of calculation.
Well, that's where he was going. He was looking for 1,000,000 volts, and I think he said that he got it this last time when he showed it. I mean, think about it. That's twice the length of my head, at least. You know what I mean? In just voltage. So,
yeah, I love what Sean was doing. I think it was the Free Energy Secrets of Cold Electricity book that had something like that, but his was like better in my opinion than I think Eric Dollar just displayed that. So I love your work, Sean. It's so beautiful, and we'll all join mine. I think we're going to make history. I just don't want to attract negative attention, and I'm trying to get my camera going, but I can't. And like literally, Gerald, how you get hacked all the time, it's so depressing sometimes, but I just try to do what I can, but I get hacked all the freaking time.
really?
Yes. It's so depressing.
It happened to me 3 times, man. Already.
But hopefully let's just kind of be on the down low and like how we say ice cream machine, just call it something different.
Yeah.
We got a different lingo.
Well, I'll be honest with you, man. I just trying to get some of these experiments off the ground, and I think everybody else is too. And I think some of share as much as you can, but don't go over the limit. I guess it's kind of the same thing you're saying.
Yeah, you got to be careful. There are keywords, and I hate if it does happen, but when you start disclosing this type of stuff, aware that it is possible. Use two-step authentication. Maybe reach out to Stephen Greer if you're having issues. Salvador Pius actually has some good head top guys too. I was in the Navy, and Sal Pius has people that are allowing him to talk about this type of thing. So there's protection if you reach out. Too big, too quick.
Gotcha. Yeah, I kind of worry about that sometimes, man, because what I'm about to do is something that's going to violate a lot of rules.
Yeah, like everything we guys do on here does.
Well, I mean, you start pulling off anti-gravity and showing it, you know what I mean, on TV,
Right.
people would be like, well, maybe we should go and visit him.
Yeah, but I'm not saying you're a small channel, but your live views is perfect. The people interested, and that's what matters. If you're not interested, don't watch. I know it goes 2 hours sometimes, but that's what we want. We don't want people that aren't willing to take the time to look into it. What we got here is good.
Yeah, I definitely agree with that. I definitely agree. Yeah, I just like the exchange of stuff. That's kind of why, we started the thing on Wednesday so that we can get some circuits out there so people can use them. You know what I mean? And my hope is that everybody who comes in and visits like you are would put in a circuit, you know what I mean? And just show everybody just a simple way that some things work and they flow together so that everybody can learn.
I have some circuits in mind. I use a simulator so you can see what the current's actually doing. I like to present like that because you can see as I'm describing it, and the simulator will give you the power waveforms and all that. Instead of diagrams and stuff like that, I like building it into a simulator and showing the principle, and you get an idea visually, actively. Scopes, you can put the voltage probes wherever you want and stuff like that, and that's the way I like to present. And it really is simple, like you said. I think 10 components or less. It doesn't take much, guys. Tesla didn't have diodes, he didn't have transistors, so you didn't have any of this stuff. He was using relays, and relays are more better to get going because they do allow that back EMF to vibrate, without blowing up a transistor. Relays really, you don't underestimate a relay.
I think we can learn a lot from that because these days we're all blowing up transistors everywhere.
Yeah, and unless you're willing to pay money for like silicon carbide kind of high voltage diodes and transistors, it runs you into money. But just to get going and explore, just use some relays. It's really easy.
Yeah. Well, I can agree with that. So Tesla's hairpin circuit on the spark gap. I was asking Sean about that. I don't know much about this circuit. I'm going to have to dig in deep on it because I don't necessarily use the spark gap. Go ahead.
It came from Electroline. He was exploring how the resistance changes with that type of circuit. And if you look at the hairpin circuit, it's almost like a dual piston. Like the two caps pump like two pistons, if you will, through a solid copper bar, and it's that interplay between the caps pumping like a dual cylinder gives you the resistance changes in the copper rod. And he used mica, and that's what I'm saying. It's what capacitors you use, because the mica can dissipate the heat. If you use a dielectric that can't dissipate the heat, it's pointless because you're just going to fry your everything. So mica is what Tesla used for that. He also made capacitors that you can look up in his patents that were like electrolytic heat exchangers. But yeah, you have to it's better to make your own, really, because the high-end capacitors are going to run you way too much money, but they're easy to build. You can literally just take aluminum foil and plastic wrap and make a capacitor like that. But the plastic wrap is not heat conductive, you know what I mean? But for stuff like that, it's good. Or you could take the aluminum and coat it with aluminum oxide, and that's really good because the aluminum oxide is a really good thermal conductor, but it blocks the current, and that's what you want. You want a dielectric that can both inhale the heat and exhale the heat, if you will.
I always wondered about that because we looked at Alexi's device and we always thought he got it out of a junkyard, and then you start to wonder, did he let that build on that plate on purpose?
I think so.
You know what I mean? Because he's getting some kind of a corrosion on the top of it. And
Yeah,
it looked... Go ahead.
Even just and temperature below being cold, the craft, and then hot on top, that pressure difference from the temperature will just anyways. So the study of where the heat's going is really important. The pressure differential just by a cold bottom and then a hot top will, lift.
Gotcha. You're kind of cutting out there.
Sorry.
It's okay.
Am I clipping?
Well, you get into the first part of the sentence and then it cut off on the end.
Well, I was just saying the pressure differential just by a temperature difference below the craft being cold and then above the craft being hot, just that pressure differential due to the temperature will give you lift.
That's interesting that you say that. I was looking into that myself.
Yeah, even if on top on the specialized craft that I'm not much about, but you can X-ray the air above the craft and ionize it, and the X-rays are what you would as the heat, and then they use bottom with superconducting, say mercury spinning and stuff like that. But they use the X-rays and stuff like that to ionize the top air above the craft.
Sure way. Okay, there's Sean. Okay, hold on. He just got my message. I wonder if I'm behind in the chat. No, I think I'm up to date. Okay. All right, you ready to take a look at this?
Yeah.
Okay. 1 second, and I'll pull it up and get rid of some of these little things here. All right. So... All right. And share that. Share screen. Give me 1 second. Let me unmute this. So I'm going to pause it for a second. The electricity you see on the left-hand side that pulls to the right, that's actually the ground wire. Then you see the Tesla coil oscillating and the energy comes out the top.
So the left is grounded?
So it's pulling the energy from the ground wire.
Oh, sweet.
So...
yeah, that's a huge distance, man. That's crazy. It's like a purplish blue. I love the color.
Yeah, well, what's crazy is he was getting those swirls in it. So I'll pause it if I can. I don't see the swirls in the top of his voltage now, but I see it pulling the ground over. So it changes effect on his testicle. I'm sorry you can't see it right there. I'm going to screenshot this real quick and then blow it up.
Sean, I wanted to suggest an experiment. Like imagine a Jacob's ladder using that type of current, and then putting 2 magnets to quench it, and then if you do that, the Jacob's ladder, the spark should fly up and kind of be like an acoustic electric wave, if you will. So if you can imagine a Jacob's ladder that got or spark quench in the middle, that spark quench should shoot that Jacob's ladder arc up much faster than a regular Jacob's ladder. Be able to modify it with audio, make some cool audio electrosonic kind of waves using a Jacob's ladder that's magnetically quenched.
Right on. Okay. Can you see what I'm talking about? There's no swirls on this. They're all straight volts now. So
yeah, the corona around is just so beautiful. I love stuff like this.
So what I was looking at is he was having swirl patterns in the top of his electricity coming out of his Tesla coil, and now there's none. Now it's just flat volt. So that's now missing now that his ground wire is, pushing over, taking it. I don't know how to explain that.
I think the video quality is different from what he uploaded you compared to this, correct? It's not going to be as high def. So you may have been seeing it in the one he uploaded to you. And then once it goes live, they have to kind of reduce the definition. So we may not catch it.
Yeah, well, let me see. Hold on. So let's go back to the other one real quick. And I'll share. Because they were apparent in everything. So you see, can you see this one pretty good? You could see how thick they are and the swirls in it. So I can't zoom that in.
I can see the swirls now. Yeah. Yep.
So, but he didn't have them in the other one.
Hey, have you ever tried a ceramic speaker magnet, sending it through that, at the base of that, see if it swirls more?
Okay, hang on. I think Sean's trying to contact me on this real quick. Let me open another one. Let you guys watch that. Okay.
Yeah, it'd be much easier to chat that way.
So
he makes it look easy, but doing stuff like that is so much more difficult than what it looks like, I can appreciate.
Yeah, well, you know how he's wrapping his coil. So, in case you missed it, what he's doing is he's wrapping it like an AC flyback. So you can see the swirls a little bit better right there. But what he's got going on is how do I say this? It's like layer cutting on that whole coil. It's not just a regular round coil. There's layers in it. So he wraps the coil around a couple times, then he goes up a layer, then he does it and goes up a layer. So you're getting multiple magnetic fields as you're going up instead of just one big one. So it's like an AC flyback setup. And in doing that, it's giving him a ton more energy.
Yeah, the obstructive and constructive interference that base coil there he's using, that makes a big difference because the near field and far field are a lot different, and it allows it to resonate with the center coil easier when it's wound conical like that. The near field and far field can interact better in a constructive way.
Yeah. So this thing is just totally awesome.
Hell yeah.
Yeah, we're going to have to see him on Wednesday, and he's got more stuff going on. So
I'll
that's
see you
always
then.
cool. Yeah.
If you guys don't mind,
What's that?
I kind of have to use the restroom.
Oh, dude, go do what you got to do, man.
Yeah.
Yeah,
I'll be back.
go. I got this. So, yeah, that's pretty cool, man. So, I'll remove that. There was some stuff I wanted to share as well. So, let me pull that up here. Let's see which one it was. So, I was looking at geometries earlier, and I wanted to show it. Where was it? Yeah, here it is. Okay. I'll show this one right here. So take a look at this. We're talking about the geometry and coils, right? And there's patterns in here, and I won't say which ones, but there's patterns that show up in certain coils that are just completely interesting to me. So I put the hexagram in one, the hexagon in one. I've also used the octagram in one. Let's see. Dexahedram, is that what it says? Use that one. It's just interesting in the way that they play out and what they do. And it is because, how to say this, you want to play a circle game with it. The line cannot cross the circle in the center, and then you'll know which diagram to use. So if you've ever seen any of these things come out and you wanted to know how that's done, just put the circle in the center and see which ones match. And then it's a process of elimination, and you'll find just about every one you're looking at. Now, there's some that cross build, and you're going to have to figure that one out. And this is how I figured out some of the geometries in certain coils is I looked at the available geometries, and I was able to tell based on what the pattern was when I was finished with it, if it was actually in there or not. So there's, some of them are making backwards patterns. So you look at the line you're actually following, but that's not the pattern you're looking at. The pattern shows up afterwards, like you'll get a stop sign in the center, or, you know what I mean? You'll get one of these other things that show up in there. So I just thought that was interesting coil building when you're actually doing it. Some of the significances of doing this is in there. So it's not always about the technical lines that you're putting into it. It's what the effect is when you're done sometimes. Then it's how you put it in, you know what I mean, in each coil you put in there. So anyway, that was just something I wanted to share with you on that. And then let's see what else we had in here. This right here is one of the most interesting things that I saw on this. And it's interesting for a couple reasons, because Victor was bringing up the different numbers on the center of the circles here, right? And the patterns. And then this actually overlays the coils in the different shapes that they have going into those patterns. So you actually get an understanding of where you're lining up with their numbers and how they affect each other. So this is extremely important when you go to do that, because now you can see what areas you're in. What's the fractal pattern of what I'm doing? Where's the vortex at? There's clearly a vortex going on in the center of this. Now this explains the dimensionality of the vortex as you're building your coils based on the shapes that you put in here. So anyway, this is just so awesome to look at. And I think when Gerald and Victor get into this, they'll be able to see based on what they're doing where each thing is. So it takes I want to say like a two-dimensional thing. So like a coil, you could say that it has width and it has height. So you get 2 dimensions out of it. But now we're going to go ahead and put in 3 to 4 dimensions in it based on the fields being created out of it. And this is kind of telling you the geometry, and it's also telling you the dimensionality that you're going to have when you're doing this. So it's very interesting. And obviously we know the golden ratio right here, right? And it tells you something right here, but I'm going to tell you that's not the answer I got out of it. It's the 180 degrees on each coil that tells you a little bit more in here. So anyway, just kind of an interesting thing I thought I'd bring up out of there. I don't want to get too far into it because that's, Gerald's cup of tea. I'll let him explain it. It's just something that I ran across that I had to show that was really interesting. So, and then there's this right here. So I don't know if anybody's really looked at this too good and understand some of the significances in this. So they always say what grows or what's above is below. And if you think of the outside of this, on the outside, if you put a tree, then it clearly shows you right under the outside rim here that the roots are growing underneath. But then it shows you a building that's growing the opposite way. So is there an inner earth? It's always an interesting question that comes out of this. If you take this and put it in 3 dimensions, what happened? You start to build the same thing we're building in these coils, that field, that same thing we were talking about on the earth and stuff, on how the field's built. So you see the top and the bottom are open. We see that the field's going through. We obviously have a north and a south in this. So if you start looking at it in 3 dimensions, not popping out like a 2 dimension, we're looking at a full 3D 3 dimension on this like it was a sphere, then it completely changes the outlook of what this actually is. Now we can start to see, okay, we have fields that are interacting on the outside portion in here. On the inside portion, we also have 2 fields interacting. We also have time dilation going on in here on the inner earth part of it. So it kind of tells you a lot more interesting facts than you would think. And you go, okay, the Aztecs always believed that we came out of, we were born in caves. And they showed the cave thing in there. But I don't think it's actually a cave that they're trying to say. It's trying to say that the caves represent the resonance in the chamber of the caves. Then if you look at this, you say, okay, if I created a resonance chamber with different geometries, what it would look like? Well, it would look just like the center of this. You would actually be able to create different frequency in that type of geometry in the center of that. So is the Earth a resonance chamber? I just find the whole subject fascinating when you can start to look at this thing a lot differently than what you traditionally look at it. Sure, it's a calendar. That's great. But there's more here. There's just more here when you read into it. So anyway, I just thought that was interesting to kind of show.
Yeah, the Aztecs were primitive. They knew more about calendar work than, it's just, how do they know? They were not primitive.
No. But it goes to more of what they knew before our time was here. They pulled something off that they knew something about the earth, the frequency of the earth, the resonance of the earth, how the fields are built. And it says it right in there.
Yeah. Especially like Schumann resonance related stuff. I'm sure like they probably knew it all, man. It's all lost with the Library of Alexandria. Like they had it all down pat and then just got wiped out. It's just such a shame. It's probably the most thing that's happened in our past, that wipeout of Library of Alexandria. We lost so much knowledge, and imagine where we could be today if that never happened.
Well, I think when we start looking at this kind of stuff, that as long as we realize that the geometry is guiding us somewhere, I think we'll be okay.
Yeah. I'm all about the geometry, but like I said, mine's a 3-space 2-time because Newton's gravitational constant is 3-space and 2-time. If you look at it in unit systems, okay, it's 2 times, but the 2 times are one toroidal and the other poloidal. And you can say the poloidal is the imaginary plane, a complex plane to the toroidal, but there's 2 axes of rotation going on in a torus, like a smoke ring. You know, it rotates along its toroidal axis, and it also rotates within that. There's two times going on, and one we call imaginary, but I hate that word. I like to say complex.
Well, check it out. So here's this coil. Do you notice the bottom's curve shape? Gerald calls the outside of this the pinch. And it's starting to get your toroidal field going.
Yeah,
So,
that's where the vector potential comes in.
Yeah, and then the inside, if you see it, there are different layers on the inside of this thing. And this is by no means like Gerald's coil. His is much better, but I'm just showing you the kind of some of the intricate things that go on in these things.
They're amazingly beautiful, you know, but we have to get down what is those relationships between the 2 times, because, you know, and once we understand that, we can not only make them beautiful but functional however we want. You know, like Sheila's a good way of kind of understanding it. Music's really involved, you know, and they're so beautiful, but like, do we want to just wind them and just hope they work, or do we want to wind one with a purpose and just know exactly what it's going to do? And I think Gerald's on that path.
Oh, absolutely, he's on that path. That's for sure. Okay, hold on. There was something in here I wanted to show. This goes more to what Merkaba was doing and his stuff. Let's see. Let's see where it is.
I'm sorry, I don't know your name, Bog Irish Ian. You're onto the right path too.
Ian definitely is.
Yeah, definitely. You guys together, you guys know what's going on. And you know, I have some research papers. Like I say, it's been like a decade since I've been in academia, and all my stuff, like some of my stuff's paywall, but I put it on Vixra so that it's available. It's like archive spelled backwards. Vixra, you can access all my papers and have a read, and it kind of explains the way I see it, and we can bounce back and forth if you're interested.
I don't think it was that one. I'm trying to find it. I can't find it right now. It came up just a minute ago. I don't think it was this one. But this is some of the stuff that Ian was talking about right here. Oh, it's not showing. Okay. This right here. Where he was talking about the relationship between the sounds and everything and all of this and which key you were in. And it goes to the octave and everything that you're in to manipulate this stuff.
Yeah, the nodal points, not many people pay attention to, but like if you were to see that as a voltage wave, those nodal points is where you actually get current. It's not nothing, you know, and it's the opposite. The nodal point of a current wave is where you get your highest voltage. But standing where you get into hairpin circuits, that's a great way to produce standing waves. And those longitudinal waves do travel at pi over 2 times the speed of light. That was shown by Eric Dollard with his longitudinal waves.
Very cool. Hold on, let me pull this up here. Sean sent me another thing of his Tesla coil, so I want to show it. Sorry. Okay, there we go. Make sure you see it.
So Sean, the sphere, like you said that augments it, correct? I'm wondering what your thought behind that is. Like, why do you think it does that? I wish he was in the chat.
Well, Sean's in the chat. I think that forms to open the system of octaves. I agree with you, Ian.
Okay.
Yeah. There's a whole lot more going on there than what we thought it was. And it's all intertwining. That's what's so crazy about this. Like, I saw Gerald stuff about what I want to say like 6 months ago. I was invited on a show with Bernie, and him and Ben were on as guests, and I started looking into everything, and Mike does, and everybody else was there. I started looking into this stuff, and I go, oh my God, dude, I was missing a whole side of this that I didn't know was there. So
yeah,
I had to go ahead.
Cool combo on this page, because some people are into the analytics and some people, they hear it and they just don't get it. And I understand, it takes so long to actually come up with your own, and yours is going to be different from somebody else's. And, the analytics, I believe, leads you on right path sometimes, but it can also be detrimental. And it really just takes building it and studying it and then deducing from there.
I just moved my camera and broke the stand. Oh, wow. Hope it stays on there. I have to glue it back. All right. Sorry about that. Yeah, well, I'll tell you why they don't get it. And I watched something earlier today, and hang on a second. I just muted the site. Sorry, it kept dinging on me. I watched something today, and it was talking about all this stuff, right? And I clearly understood why people do not get it. It's because of the way they explain it. It's like I was trying to say earlier. They basically take a sheet and then they put a ball on it and they tell you, you know what I mean? That's space time. And I think it's a completely garbage explanation. It does not take into effect, you know what I mean? Because the fields go around the Earth. The Earth is a sphere. They're trying to tell me that it's like, let's go back to Tron, the first one, not the second one. Let's go back to the first one. Let's all, you know what I mean, put on our neon and let's all go running around, because that's what they think this is. And it's absolutely horrible, because when you start doing the test, they don't match that at all.
No, and their 5 dimensions is 4 space and 1 time. My 5 dimensions is 3 space, just like Cartesian, makes sense. Up, down, left, right, front, X, Y, Z, and then 2 times. And those match the dimensions of Newton's constant. So why are we going and saying 4 space and 1 time when, in analysis is 2 time? And the closest is Kaluza-Klein. That's the 5D, like where I think Einstein, he started to agree, but then they hushed because they knew that was once they hit Kaluza-Klein theory, that's where it went silent with the unified field theory.
Well, they just had to start saying ether again, and then explain how you build an ether. And if you can explain that, then the geometry matches. Then you start to get the amplification that matches. Then you start to get the actual geometry of each object matching the frequency. It just makes more sense when you actually do it versus let's pull something out of our rear that sounds smart.
Yep. Nothing beats doing it, because you'll expect something and it'll be completely different, but sometimes the difference is good if you explore it, and it leads to more discovery, better than what you thought. But until you actually start putting your hands on these things, you can think about it all day, and it could lead you down a rabbit hole that will never get there.
Yep. It's like I try to tell people when you talk about heat in the system, you know what I mean? Or you talk about frequency in a system, something like that. once you start working with this, you're going to start to understand things a lot different because you bring up the frequency, the amps go down. You bring down the frequency, the amps go up. I mean, it's not a let's put in this many, volts and this many amps, and that's what I'm going to get. And then you wonder why your circuit blows up. Well, because you didn't account for things like you go with a MOSFET or a transistor, and there's a heat rating on it, right? Well, not a lot of people take that into account. They go, how many volts, how many amps? You know what I mean?
Right.
And then they go, okay, why did it blow up? Well, you have no idea what you're doing. You didn't look at the heat.
I think the slew rate is really what's screwing them. Don't understand what slew rate is, and that's what Tesla was preaching is the rate of change. The slew rate, just look into that and it will help you, like Nathan's saying. Basically the higher the frequency, the lower the current, but it also matters about the width of that pulse. What the slew rate is to get a better understanding of why they're frying out. And use relays to start with because they're rugged, and you power with the pulse width modulator and just use it as a switch. Don't use the relay in the actual circuit. Just use that switch because once you charge capacity, throw the switch, from the battery to, I call it a bell circuit, but it's a tank circuit technically. The relay can handle that completely different from a transistor. That's where the transistor would fry. But the relay switch can handle that back and forth with no problem.
So a trigger circuit.
You're using the relay, your pulse width modulating the coil of the relay and just using the switch.
See, I put the switch on the low side. So 5 volts, you know what I mean? And then I put the power on the high side. So now I get all of the switching in. Basically I can control the the frequency on it, and then I can also control the duty cycle. So I can control how long that pulse goes, and then I can also change the frequency higher and lower based on that low side, while the high side just runs straight power.
Yeah. I would say try to switch on the high side. Tesla mentions that in a lot of patents that he switched the high side. So it might be worth exploring, and you can do it with the relay, like PN, PMP, and blah, blah, blah. You don't have to worry about, just use the relay, because when you're trying to switch, getting going, and you got to learn all these NPNs and blah, 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 you high side or low side and blah, blah, blah. But, just use a relay and switch both sides and study what happens. There is a difference between the high and low side switching.
Yeah. It's always interesting to get into that. I always keep it simple. You know what I mean? So that people can learn it and then they can dive into that and find the difference.
Exactly. Yes. Imagine being Tesla without any diode. Not even a basic diode. This guy didn't have. I mean, he made magnets, but he didn't have it, and he did it. So what does that tell you?
Yeah. Well, it tells you he knew a lot more about energy than we currently do. You know what I mean? As a general thing. But he also didn't have to deal with electronics and things blowing up in that level. He could just build it as big as he wanted.
Right. He was a master at building them. And, like I said, you'll pay a fortune trying to find that right capacitor, the right capacitance and voltage rating, blah, blah. Just make it. And it's not that hard.
Yeah.
But yeah, Tesla was just a master builder, and he started with, his first patent was a commutator, which is basically a cylinder that acts as a relay. So that's where he started. So that's the roots. It's just a cylinder that has insulation, conductor, insulation, conductor. He spun it, and that's how he controlled it, like a Newman motor, where you have the contact brake, So it's basically like a spinning relay that he started with. That's his very first patent, was a commutator.
Okay. Hey, I wanted to show you this real quick and get your thoughts on it. Let me see if I can't share it real quick. So, okay. What's going on here is the microwave is being used as a Faraday cage. And then inside, he's got the lights in there, okay, LED lights. And then he touches a line on the outside, and it'll actually turn on the lights on the inside. So let me go ahead and play it and show it for you. Make that bigger. I don't see a power source on that.
I would say it's body capacitance.
Body capacitance?
Yes.
So do you think the microwave is working as a Faraday cage that you can run between it if you put a wire?
I think the microwave is just to show there's no external power source. I don't think the Faraday cage even matters, just to tell you the truth. I think he's demonstrating that there's no way that any external power source could be doing that other than by touching it by hand, which is where the body capacitance is powering it.
So, okay, I got a question. Can you explain the body capacitance so that we understand it?
Yeah. So if you like, I mean, it gets kind of into esoteric things, but like when you study, how ancient Chinese people used to kind of use wind bending, if you will, what they would do is they would lay on the ground, okay, and you're parallel with the ground, and then they'd stand up. And then they lay on the ground, and then they stand up. And by rapidly doing that, you're charging your body, and on your body can hold a capacitance. And you can use the earth itself just by laying down, standing up, and laying down to charge your body up. And the more you do that, the more your body gains capacitance. But all the cells in your body act like small capacitors. And just by sizing your capacitance, you could bring it up so that you could store more charge. But normally you don't store much charge because you're not purposefully trying to increase your body capacitance. Regular body capacitance, that's how you can, grab the antenna of an old TV and tune in, because your body's acting as the capacitance,
So hold on. Let's go ahead and take that one down. I'm going to pull another one. Okay. Let's see. And let's see if I have it real quick here. Okay. Found it. So I thought the same thing was going on with this. So I'll just show this.
The coil.
Real quick before I start, what I think is going on is I'm getting vibration in my big coil that I'm pulling the wire from, and it's shaking the table, just so you know what's going on.
The big spool of wire got a resonance frequency. Now let's go ahead and see that one more time. Pay attention to the bottom left-hand corner of your screen. Look at the big rod that's sitting there. Watch this coil resonate. It's going to shake the table. This full of wire is the one that's making the resonance.
Okay. So, do you think body capacitance working there?
Could be with the magnetic wire, the friction of you holding it could add a little bit of body capacitance. I think a really cool way to look at body capacitance, if you could look it up, is a theremin instrument. If you've ever heard of that,
Okay. No, I haven't.
it's really cool. Joe might have heard of it. He's a musician.
Okay.
It's spelled TheRemin.
Say that one more time. 2HD.
Sorry, THE like V
Okay.
REIN. Theremin.
Let's see. I hope I got it right. Not getting any pictures of instruments.
You could probably find a good YouTube video. You don't even touch it, and you make the sound by just.
Is that the radio thing? The radio sound?
It kind of, well, we got to look it up. It's not.
Yeah,
really
it is. It's what Sheldon used on The Big Bang Theory.
Yeah, maybe. I haven't seen that, but sounds like something they do.
Well, hold on. Right there.
Yeah. Yep.
Yeah,
That
it's
works.
the same thing.
That works on body. Yeah,
that.
it works on. It's body capacitance. You
Yeah.
make music without even touching it.
Thought I recognized that thing as soon as I saw it. That's what he was doing on there. He was annoying one of the other guys on the show with it. I thought it was hilarious. So, yeah, that's pretty cool. All right, I wanted to show real quick. The guy sent me 3 experiments, so I told him I would show them. So let's take a look. And he's dealing with the same thing. So, okay. Let's see. Make sure everybody can see that, and I'll hit play on it. So it looks like he's got the same coil, the same lights, but I'm worried about where the other wire is connected. So let me.
You see those 2 diodes? It looks
Yeah.
like an Avermenko plug. You can do that with Avermenko plugs to pick up the electric field. That looks like what he's doing is using an Avermenko plug.
Okay. And he's just picking up the electric field in the coil? Is that what's going on?
Yeah, you can literally just take 2 LEDs and pigtail them and set it to it. But they got to be, one up and one down.
Okay. You cut out most of what you were saying right there. Can you say it again?
Yeah, if you take 2 LEDs, oriented one up and one down and pigtail them, up the electric field from that coil.
Okay. All right. And there's one more.
Don Smith used to kind of probe around his equipment. He would, make an Avermenko plug detector, if you will.
Okay. This one right here. So I think this, he was just showing how this is flowing and how he wanted it to work. So anyway, all right. What's that? Sorry about that, man. I always want to look when people send me stuff and see what's going on with it. You know what I mean? Still there?
Yeah, I'm here. Sorry, my dog. She's not used to me doing this, so she's like freaking out.
Right on, man. Right on. Yeah. Okay, so let's see. Sorry, just going through the chat real quick. What's up, Bernie? I'll show that. Everybody's having a great day, man. We're learning a lot. So, in the beginning of the show, we got to see Mr. Linus is, I'm saying that always wrong, and I know it.
Mr. Laney is like miscellaneous.
Ladies, man, I don't know what it is with me. I always
Just call it just Mr. or whatever. It doesn't matter.
Mr. whatever, Mr.
Yeah.
L. No, we saw a really cool thing that had to do with the monopolar motor and a different take on it that had to do with liquid and dielectrics in there. And Bernie, it's right up your alley, man, on some of the stuff that he was doing there. I wish I could rewind the show and show you, or his camera worked. We can show it again.
Yeah, if you could catch the beginning, that's when my camera was working. I was just able to get that in there, and then my camera glued. But that is what I think this community can use as a power source for, like Stargates, if you want. I mean, 100 kilowatts is a lot of power, guys. And, I'm just putting it out without a patent. I'm just doing it out of the love of my heart. It's a gift to everybody. And it's a good starting point as a power source. And then the propulsion will get there.
Yeah. Well, I think I'm pretty close to that propulsion now. So
yeah, you're the man.
We're getting there, man. I mean, at least we're trying anyway, It's yeah, I got a few more little stages to go through, and I think I got it. I'm working with somebody on some different parts of things, working with Brandon with some high voltage stuff that has to do with the difference we were talking about in the field. So, and it's producing results of lifting weight. So I wanted to amplify that, you know what I mean? And then from what I understand, that the weight itself is not a problem at all because it's actually the force that's driving it. So,
and force is the product of pressure and area. Think about it simple.
Yeah, that's what he keeps saying too. It's real simple.
It really is once you get it.
Yeah. You know what it is?
You just got to pound it over and over until they get it.
It's that little experiment in the beginning. It's that I got a success. Now I need to build on it. And that's all it is. It's
We'll get there, guys. I'm telling you. I think this could be a historical group, to be honest. But I was gonna say something. If you missed it, I sent out an email address on Mr. Lanius at Custom Electrets that's not working. So if you want to contact me, it's Mr. Lanius Engineering at gmail.com. Just throwing it out there.
So the one that you sent me, is that the same one?
Yeah, that's it.
Okay.
I built that web. Sean was inquiring. I literally built it that day. So it's glitching out on me. And once I get it working, that one would work. But I kind of, it's better not to have that one right now anyways until I get my equipment. The best way is Mr. Lanius Engineering at Gmail.
Gotcha. I'll share it with the group here so they can get a hold of you. So right on. So okay. Sorry about that. was just looking at everything. So what else we got going on? Is there anything else? Anything going on? Anything you want to talk about?
I the energy. I'm just so. I kind of partied too much last night. I'm just not feeling good today, man. Me and my friends went all out.
Oh, well, yeah, I've had those days. You wake up and you start to see sparklies in the air and you don't realize what they are right away. Yeah, I had those days.
But it's always fun chatting with you guys. I mean, it seems like we could talk all day, but unfortunately we all have different schedules and,
Yeah.
but
Well, it's late where you are right now, isn't it?
the 3 hours ahead of you. It's 3:25 right now.
Oh, wow.
I live in Georgia. So you got to be like California?
California, yeah.
Yeah. Yeah, so it's the biggest time gap.
Right on there. Well, you know what? You came on the show, man. You're part of the crew. So anytime you want to pop back on, let me know in the chat or something. Just say, hey, let me on. I'll send you the email. You know what I mean? And then you can come on anytime you want and discuss everything. I really enjoy when we have people like you come on and then we have crosstalk between all the other inventors that are going on. Like,
yes.
For like you. Go ahead.
Rewatch it because I want to see the comments and everything, so I do go back in and watch the comments and stuff, and I can't catch everything right now, but I look back on it, and it's just such a blessing to have a group like this. So thank you guys so much. It's nice to meet everybody.
Yeah, we got a good group, man. We got an outstanding audience in the chat, and I think eventually everybody in the audience will join the show at some point. You know what I mean? That they're comfortable and ready to do so. Because I think there's always people out there that are holding back a little bit, and they got something. You know what I mean?
Yeah, I hope they do.
Yeah. So it always makes it more interesting, man.
Absolutely, guys. But
well,
I guess
right on.
Unless you have any questions.
No, I think I'm good for right now, man. I think I think we're pretty good, man. I think honestly, I'd love for you to get on here with the rest of the team and really get a good show like going if you're available on Monday when everybody gets together. If you got a little bit of time, it's a good group, man, and I think the crosstalk will be awesome.
Yeah, I look forward to it. I'm going to try to free it up. I've been really busy, but if I can do it.
Right on, man. Right on. Well, thank you for coming on. I want to thank everybody in the chat. And if there's anything else you want to say real quick before we finish.
I appreciate you guys. And let's go to the stars.
Right on. I agree, brother. All right, guys. Thank you very much. And have yourself a great Sunday and enjoy the football today, man. All right. Talk to everybody later, man. We're out.